All right, let's dive into a story that's straight out of a cyber thriller. We're talking about a zero-day vulnerability, a flaw that could have left a huge chunk of the internet wide open. This is the anatomy of a hidden backdoor, a look at the digital guardians who found it and the race against time to fix it. We think of the internet as being protected by all these layers of security, right? Like a fortress. But what if I told you that one of the main gates of that fortress, well, it had a secret feature. A feature that could tell it to just turn itself off, to just unlock and wave anyone through, no questions asked. That's pretty much exactly what we're talking about here. A critical flaw found in one of the internet's biggest protectors.
Okay, so to really get what happened here, we've got to set the stage. Let's meet the key players on this digital battlefield.
So on one side, you've got Cloudflare. And look, even if you haven't heard of them, I guarantee you use them every single day. They are an absolute titan of internet infrastructure. Think of them as this giant invisible shield that protects a massive part of the web from attacks. They're the ones keeping things fast and, more importantly, safe. They are the armor. And on the other side, well, they're the ones testing that armor. Meet FearsOff. These are the protagonists of our story. We're talking about an elite team of cybersecurity researchers. You can think of them as digital guardians, right? The ethical hackers who are out there hunting for the cracks in the system before the bad guys do. And on October 13th, bingo, they found something big. This quote right here is from Cloudflare's own report, and it really marks the beginning of this whole story. FearsOff found a critical flaw in their validation logic, and they did exactly what the good guys are supposed to do. They picked up the phone and reported it. So the big question is, what exactly did they find? To get that, we need to zoom in a bit and look at the tech at the heart of all this. It's something called the ACME protocol. And the best way to think about it is like a digital doorman for the internet. Okay, ACME, it stands for Automatic Certificate Management Environment. The key word there is automatic. You know that little padlock icon you see in your browser? The one that tells you your connection is secure? Well, ACME is pretty much the reason that exists. It's a system designed to automatically hand out and renew those security certificates, basically making the web a safer place for all of us without anyone having to think about it. All right, so how is this whole thing supposed to work? Let's stick with an analogy. Imagine the certificate authority, the CA, is like the manager of a very exclusive club. The manager gives a secret password to the doorman. The doorman then has to put that password in a specific, known spot. Then the manager comes back, checks that the password is there, and says, yep, this is my club, you're legit. Once that's done, ownership is proven, and bam, a security certificate is issued. It's meant to be simple, effective, and totally secure. Which, of course, leads us to the million-dollar question, right? How on earth does a system that's literally designed for security accidentally create a massive backdoor? How did our trusted doorman become the weak link? Well, the answer is kind of subtle. It all comes down to a tiny, single flaw in the logic. A little crack in the code that took a security feature and accidentally turned it into a weapon. And here it is. This is the scene of the crime. This specific digital address, the ACME challenge path. This was the exact spot where that digital doorman was supposed to be checking IDs. But instead, for a brief moment, it was programmed to just turn a blind eye. Okay, this is the absolute key to the whole thing. Here's how it should work. When the real club manager shows up to check the secret password, Cloudflare tells its security bouncers to just stand down for a second. Let them through. Now, these bouncers are what we call a web application firewall, or a WAF. It's a security system that's constantly checking for bad guys. But here was the flaw. The system was telling the bouncers to stand down even if a fake manager showed up with the wrong password. The password check would eventually fail, sure, but for that critical moment, the bouncers were already looking the other way, and the gate was unguarded. And this is exactly how an attacker could have strolled right past security. Step 1, they send a request to that special ACME address, but with a totally fake token. Step 2, Cloudflare's flawed logic sees this, and what does it do? It mistakenly lowers its own security shields, the WAF. Step 3, that malicious request, now totally unchecked and uninspected, gets passed right through to the customer's actual server. And just like that, the fortress walls are gone. The security perimeter is bypassed. So the moment FearsOff found this backdoor, the race was on. The clock started ticking. This next part is all about slamming that door shut before anyone else could find it. And here's how it played out. On October 13th, the moment they found it, FearsOff privately reported it to Cloudflare. This is absolutely crucial. It gave Cloudflare's engineers the runway they needed to develop a fix and deploy it, all without tipping off any attackers. It wasn't until January 19th, once everything was patched and safe, that they went public with the details. This right here is a perfect example of responsible disclosure in action. And, the fix itself was actually pretty straightforward, but so critical. Basically, they just updated the logic with one simple rule. The security bouncers, the WAF, would only stand down if the request came from the real manager with the correct secret password. That's it. A simple tweak, but it slammed that backdoor shut for good. So, okay, a bug was found, a bug was fixed. Story over, right? Well, not quite. Because the real lesson here isn't just about one little flaw. It's about the entire ecosystem that's built to keep us safe online. You want to know the most important number in this entire story? It's this one, 0. That's how much evidence Cloudflare found of any malicious actor ever using this vulnerability. The backdoor existed, but it seems no one ever actually walked through it. So why not? It's because the system actually worked. It did exactly what it was supposed to do. You had ethical hackers at Fears Off, often incentivized by bug bounty programs, who found the flaw first. They practiced responsible disclosure, which gave Cloudflare the time to fix it without causing a panic. And then Cloudflare was totally transparent about the whole thing, which builds trust. This is what a healthy cybersecurity ecosystem is all about. And really, it all leaves us with this one big question. We live in a world that is completely built on code, and that code will always have flaws. It's just a fact. So the real question isn't, are there bugs? The question is, who's going to find them first? And if this story tells us anything, it's that the answer lies in that constant, quiet, and absolutely critical partnership between the people who build our digital world and the people who are paid to try and break it.